Hello everybody. This is lesson 11 of the lecture Macroeconomics. I will discuss the slides 58 to 66 of chapter 3, the neoclassical model. So far we have deduced the capital market of the neoclassical model and determined the equilibrium interest rate on the capital market. As we have also seen, the real interest rate determines consumption demand of households and investment demand firms, hence total demand for goods, which is equal to consumption demand of households plus investment goods demand by firms. This means, however, that the equilibrium on the capital market determines also the total demand for goods. The next diagram displays this interaction between the capital market and the demand for goods. On the left-hand side we have the capital market with savings supply from households and investment credit demand by firms. On the right-hand side we have the market for goods with the consumption demand of households. We know, however, that consumption demand of households is only one component of total demand. The other component is demand for investment goods. Since firms finance their demand for investment goods completely with credits, the demand for investment credits and the demand for investment goods are identical. In other words, investment appears in fact two times in the neoclassical model. On the credit market as investment credit demand and on the market for goods as investment goods demand. We can now use this identity to construct the investment goods demand on the market for goods. To do so, let's simply start with an arbitrarily chosen interest rate level of, say, 1%. Now we can measure the total investment credit demand at this interest rate on the capital market. So it's this line segment here. And to find the total demand at an interest rate of 1%, we simply add now this investment goods demand to the consumption goods demand at an interest rate of 1%. So we shift this line segment to this point here, and we receive this green point. So total demand for goods at an interest rate of 1% is equal to this large line segment here. The difference between the green point and the consumption demand, this line segment, is investment goods demand at an interest rate of 1%. Since for simplicity all curves in this diagram are in fact straight lines, it is sufficient to determine total demand at another arbitrarily chosen interest rate level in order to find the total demand curve for goods. So let's choose an interest rate of, say, 2% and apply once again the same procedure. At this interest rate, investment credit demand is now somewhat smaller as before, this line segment, And now we have to add this line segment to the consumption demand at an interest rate of 2%. This point here, in order to receive the total demand at an interest rate of 2%. So let's shift this line segment to this point here, and let me know that this green point is now total demand for goods at an interest rate of 2%. In this way we have now received two green points, this one and this one, which both lie on the total demand curve for goods. Since we have only straight lines, the other points of the total demand curve must lie on the straight line which links the two green points. This curve here. You should take a straight edge and check this relationship for other interest rates. You will see it works. So now we have successfully constructed the total demand curve for goods. It has two components: consumption demand for goods plus investment demand for goods. So we are now able to determine the total demand for goods at the market equilibrium interest rate. The market equilibrium interest rate is determined on the capital market. In this example, it is equal to 1.5%. At this interest rate, savings supply by households equals investment credit demand of firms. If we extend this interest rate level now to the market for goods, we are able to determine the total demand for goods, which corresponds to this capital market equilibrium. This is the resulting consumption demand, and this is the resulting investment demand. Together, both demand components equal total demand for goods given this capital market equilibrium. This leads now to the question whether total demand for goods is also equal to total supply of goods given this capital market equilibrium. So far we have not determined the supply of goods on the market for goods. We will do this now, and we can use a mathematical trick to determine the position of the supply curve. What we will in fact do is we use our knowledge of the budget constraint of households to determine the position of the supply curve. We will do this in the following way. From the equilibrium on the capital market, we know that savings supply of households equals investment credit demand of firms. We also know that total demand for good equals consumption demand plus investment demand. From this follows that total demand for goods also equals consumption demand plus savings supply, since investment demand is equal to savings supply by the equilibrium on the capital market. From the household budget constraint, we know that consumption plus savings is equal to the total GDP produced in this economy, because total GDP equals household income. As a result, we know that total demand for goods is always equal to total supply of goods. I think this is a quite astonishing result. Since consumption plus savings is equal to household income, and since we know that household income is equal to GDP, we can conclude that the demand for goods always equals the supply of goods. This implication of the neoclassical model has a special name. It is called Say's theorem, because the neoclassical economist Jean-Baptiste Say has first discovered this relationship. The production module that we have derived in the last lesson tells us that the supply of goods depend on labor supply, on labor input determined on the labor market, and on the capital stock, which comes from the previous period, as we have seen. Due to Say's law, the total demand for goods at the equilibrium interest rate determined on the capital market is always equal to the supply of goods. Since the supply of goods does not depend on the interest rate, but on labor input and capital stock input, it appears in the goods market diagram as a vertical line. It is not affected by changes in the interest rate. We would have to change the position of the supply curve, however, if labor input changes or the capital stock changes. If they get larger, we have to shift this curve to the right. If they get smaller, we would have to shift this curve to the left. To sum up, we have now detected the following circular relation. The value of goods production, which is the supply of goods, is equal to household income, the value of labor and capital income of households. Given the budget constraint of households, their income equals household consumption plus household savings. Given the equilibrium on the capital market, savings supplied by households is equal to credit demand of firms. Credit demand of firms, however, is equal to investment goods demand of firms. So, consumption demand by households plus investment goods demand by firms is equal to the total demand for goods. Now if we take a look back to the first position of this equation, we find that the supply of goods is equal to the demand for goods. So we have now, in a sense, mathematically proven Say's theorem. Now, this means that given the assumptions of the neoclassical model, the value of the demand for goods always equal the value of the production of goods. Consequently, the demand for goods always equal the supply of goods. In other words, goods supply creates its own demand via the income that is created by goods supply. This is one reason why demand-side cause business cycle fluctuations do not appear in the neoclassical model. We will analyze demand-side shocks under the neoclassical model, and you will see that exactly for this reason, Say's theorem, they are not able to create fluctuations under these assumptions. The neoclassical economist Jean-Baptiste Say was the first who discovered this relationship under the neoclassical assumptions. Therefore, it bears his name. So much for this lesson. In the next lesson, we will complete the neoclassical model by adding money supply and money demand.